Hi friends, this is Sarvajan here. Welcome to my networking channel. Hope all are doing good. And today the topic I am going to discuss about quality of service. So why quality of service? Quality of service is designed as an alternate method to merely increase the bandwidth and also to get rid of delay, jitter and the packet loss in the traffic. So network traffic is affected by several factors like delay. So delay defines a latency that happens whenever we are sending traffic from one end of the network to other end. So that what we call as a delay. So jitter describes the fragmentation that occurs when the traffic arrives at irregular times or in the wrong order. So jitter is nothing but the varying amount of delay. So most of the voice and video traffic will be affected by the jitter and delay. And the third thing is data loss. So this occurs when there is a congestion. So when the link congestion happen, so when the speed of the ingress traffic is more than the egress traffic, or when the bandwidth exceeds. For example, assume there are two scenarios. One is shaping and policing. So normally shaping will be done at the customer end, right? And the policing will be done at the ISP or the provider end. So whenever you are sending any traffic to the ISP and say, and but the link capacity is not able to handle the excess traffic, what happens? That it can lead to link congestion and the packet drops. And also it can also have a negative impact on the voice quality. So to avoid such situation and to get rid of all these issues, we are using QoS, what we called as a quality of service. So let us understand the delay types. There are several types of delay also we can each which will impact the network traffic. One is a serialization delay. So what is serialization? The time taken for an interface to encode bits of data onto the physical media. So already we know what is encoding is nothing but converting data into signal on a physical wire, right? So whenever you are sending any data on a physical cable, we'll encode the data into signal and we will send it on a physical wire. So that delay what we call it as a serialization delay. So the time taken to encode the bits of data onto the physical media. Propagation delay is nothing but it is a time taken for a single bit to travel from one end of the network to another network, what we call it as a propagation delay. So another one is forwarding delay. So that is time taken for a router or a switch to move between ingress and an egress queue. So router or a switch has two interfaces. One is an ingress or an inbound and egress or an outbound queue. So there are two queues what we call as an ingress and an egress queue. So the time taken for a router or a switch to move between ingress and the egress queue what we call as a forwarding delay. And what is a queuing delay? So the time spent in an egress queue waiting for a previously queued packets to be serialized on the wire. So what is a queue is nothing but it is used to store traffic before serializing the data onto the wire. So what happens? Sometimes there may burst excess traffic. So what happens, instead of sending all the traffic at a time, we will buffer or queue some data before serializing the data on the wire. So that delay what we called as a queuing delay. So the time spent in a egress queue we call it as a queuing delay. So the network delay is a time spent in a WAN cloud. We call it as a network delay. So these are the factors which can also affect the network traffic. So taking all this into consideration, we have designed the quality of service. So now let us understand the QoS methods. First is the best effort. So best effort is nothing but it is treated on a first come first serve basis. So this is a default behavior of router and the switch. So always the internet forward traffic on a best effort basis. So let us take a fire truck or an ambulance example. So that is a high priority traffic. So this traffic always will go ahead of other traffic, right? So this even will not obey the normal traffic rules. So compared to this best effort scenario, even the ambulance or the fire truck vehicle should stay within the normal traffic flow. Irrespective of this priority, still it should stay within the normal traffic flow. So that is the purpose of best effort scenario. Even if it is a high priority also, there is no need for high priority because even all of the traffic should stay within the normal flow of traffic. So that is the best effort. So with this best effort scenario, the traffic will be forwarded via best effort and also as quickly as possible. So that is a default behavior of router and switches. And second is an integrated QoS. So what we call it as an end-to-end or a hard QoS. So what is the integrated? It is nothing but an end-to-end QoS. Why means we are using a specific protocol called a RSVP. That is a resource reservation protocol, which is a signaling protocol which is used to reserve the bandwidth and delay that is required for a flow. So let us take the same example of fire truck or ambulance. Assume there are four intersections. So before the fire truck arrival, each and every cop standing at the intersection will notify other cops that the vehicle is arriving. So what happened based on that? All the four cops at each and every intersection, what happened? They will plan for a special lane. so that the other traffic should not get disturbed, right? So they will plan for a special lane and they will direct the traffic, especially these ambulance or fire truck, from source till destination. So there is special lane is reserved from source till destination. So each and every intersection we have to reserve that special lane. So that is the purpose we call it as an end-to-end QoS. So let us come to this network. Assume there are 4 routers, say router 1, 2, 3, and 4. So I have to enforce end-to-end QoS and all these things. That means I have to enforce this reservation on each and every device. So that is the reason we call it as an end-to-end QoS or a hard QoS. And this is not scalable. Why? Means I have to enforce this reservation from router 1 to router 4. All the routers I have to do. And the third thing is differentiated QoS or diffs QoS. So it is direct opposite to integrated QoS. So this is assumed that before the traffic arrival, so none of the thing is aware that the traffic is coming, right? Say especially we'll take this ambulance or fire trucks. So once it arrives, what happen? Each and every cop will decide how to handle the traffic flow. So that is the thing we call it as a differentiated QoS. So in this QoS, there is no specific reservation. So each and every cop or each and every device has to decide how to handle the traffic flow. So how we are differentiating is there are 3 types of differentiation. One is the class map. So class map is nothing but traffic will be organized into classes. So first we have to classify the traffic. So there are several types of traffic will transport over the data. It can be a TCP traffic. So it can be UDP traffic and it can be even voice or video traffic. So first of all, I have to organize or differentiate the traffic into classes. And the second thing, I have to give the level of service. So if I want to prioritize the voice traffic and the video traffic, so then I have to give priority. So that level of treatment is given by policy map. So policies are created to provide a specific level of service. And third thing, what we'll do after that, we'll apply into the interface. So these are the class map, one is a policy map, and third is a service policy. Once it is done, we'll apply it to the interface. So this also we call it as a soft QoS. So this is directly opposite to integrated. So integrated QoS, there is a reservation is there, but in differentiated QoS, there is no reservation, and this is more scalable because each and every device has to decide how to handle the traffic flow. So what are the QoS tool? One is the classification. So I already told what is classification is. First and foremost thing, we have to classify the traffic. So what is the purpose of classification and marking? Both comes in conjunction with each other. Why? Because first I have to organize the traffic into different types like voice, video and other traffic. Then I will mark the traffic. What is the purpose of marking is nothing but if I want to prioritize the marking, I can set the marking level. So there are 2 types of marking, layer 2 and layer 3 marking. So layer 2 marking will do at the frame level and layer 3 marking will do at the packet level. So marking is mainly done to prioritize the traffic. Say if I want to prioritize voice and video traffic before the data traffic, then I can prioritize accordingly. So that is the purpose of classification and marking. So these are the one of the QoS tool. And the second one is queuing mechanism. So I already told what is queue. Queue is used to store traffic before it can be processed. It is more or less like buffering the traffic. Before sending the traffic, at a time if you are sending the large amount of traffic over a single link, so we will queue the traffic and we will send it over the WAN link. So that is the purpose of queuing mechanism, and it is also used to service the high priority traffic. So let us take the example priority queuing. So priority queuing, there are several factors. It is classified as high priority queue, medium priority and low priority. So what happened first, the high priority traffic will go first, second is a medium priority, third is a low priority. So first the high priority traffic will be surfaced, second is a medium priority, third is a low priority traffic. So that is the purpose of queuing mechanism. So the queue is nothing but it is used to store the traffic before it can be processed. So that is the purpose of queuing. And the third thing is congestion avoidance. I already told when the congestion happens, when the rate of ingress traffic is more than the egress traffic, right? So when the ingress traffic is more and when we are sending the traffic at the service provider end, if the traffic is more, what happen? It can lead to drops or packet loss. So to avoid that and to detect the congestion earlier, we are using the congestion avoidance mechanism. And there are 2 methods, what we call it as a random early detection and weighted random early detection. So these 2 methods will detect the congestion early and it can also avoid the packet loss. So that is the purpose of queue congestion avoidance. So these are the 2 mechanisms. So then let us understand the basic methods of implementing. One is a legacy QoS. So it is an old method of enforcing QoS via command line interface. This is the oldest method. So now we are using the modular QoS CLI, what we called as an MQC, which is a improved command line implementation. So first we'll organize the traffic and we'll classify into class map. Then policy map is used to apply a specific level of service. And third thing, after that, I will apply to the interface using the service policy command. So these are the three steps involved in this MQC. So first is the class map, right? We'll organize the traffic, whether it is a voice or video. Then we'll do the marking, whether we are going to do layer 2 or a layer 3 marking. Then we'll apply the specific level of service. We'll prioritize the traffic, video or voice. Then once it is done, then we'll apply, then we'll decide whether we have to apply on a ingress or a egress interface. So that is the thing we have done in MQC. So it is a improved command line implementation. And the final thing is auto QoS. So auto QoS is nothing but an automated method. So instead of manually defining, it will run a discovery process to analyze and classify the variety of traffic types. So once I enable the auto QoS, it will automatically analyze and classify the variety of traffic types. So that is the purpose of auto QoS. And another thing is Cisco SDM. Cisco SDM is nothing but a Cisco Security Device Manager. So it is a web-based management GUI for monitoring QoS, right? So for configuring and monitoring the QoS, we are using this Cisco Security Device Manager. So it provides a graphical method and for configuring and monitoring QoS. So what are the traffic it monitors? Real-time traffic, business critical traffic and best effort traffic. So real-time for VoIP and signaling traffic, business critical for network management and routing traffic. So these are the key points you have to keep it in mind coming to QoS. So QoS is a quality of service which is used to increase the bandwidth and to get rid of delay, jitter and packet loss in the network traffic. So these are the factors which will affect the network traffic. To overcome all these issues, we are using the quality of service. So I hope you enjoy this video. Thanks for watching. Please subscribe for more videos. Thanks and have a wonderful day. Thank you.